Today in MT1502L, practical based on MT1501, that is matrix algebra and coordinate geometry. I, Dr. Savan Patel, from the Department of Mathematics, St. Xavier's College. First of all, welcomes you in the St. Xavier's College and starting the practical 8A. It is a practical number 8. This A for the first lecture of the practical 8. It is about the various coordinates in R2 and polar equation of line. Okay. For the practicals number 1 to the practical number 7 will be done by DJB sir, double J Bhatt sir. Practical number 8, 9, 10 and 11 will be done by me. Practical number 12, 13, 14 and 15 will be done by PGB means Prasant sir, and practical number 16 will be again done by DJ Bhatt sir. Okay. You are having a course. There you can see that what is the content of this. So before the starting of the practical number 8, I will require the theory portion of the practical number 8. That is about the polar and Cartesian coordinate systems conversion. So if you haven't studied about that, go through that theory portions lecture and then start here. I am quickly recalling the things about the polar to Cartesian conversion. First of all, in the Cartesian coordinate system, the point somewhere here, that is xy, means we are having this point, say origin 0 0, and if I want to reach to this point, then its coordinates are x and y, x comma y. If I draw a perpendicular from this point to the x-axis, then this distance is my x and this height is y. Now, if you draw here perpendicular on y-axis, then this height is y and this length is your x. You know, by the rectangle, this will form a rectangle because this is also perpendicular, this is also perpendicular, this is also perpendicular. So this will form a rectangular, means this and this will x and this will be y. So if I want to walk from 0 0 to this point, then all I have to do is in the x-axis direction walk x much unit. Better we write x0 and y0 so you will not get confused. So here if I want to reach to this x0 y0 point, then in x-axis direction I will walk x0 unit, and from this point I will reach to this point. That point's coordinates are x0 0, and then walk y0 unit in y-axis direction, and then you will reach to the x0 y0, or you walk y0 unit in the y-axis direction, then you will reach to 0 y0 point, and then walk x0 unit in this direction, means x-axis direction, and you will reach to the x0 y0 point. That is the one way to reach this point x0. Actually, two ways to reach this point x0 y0. But instead of walking in those two directions, you can select the better shortcut way. You know, is this one. So from if I know this angle, then I will rotate myself at x0 0 0 with the x-axis. If this angle is theta, then I will rotate myself theta angle, and Then if I know this distance is r, then I will walk in that direction r unit to reach my point x0 y0. So that is the another way to reach our point. Okay. So there is a nice relation between this r and theta. So you can write this x0 y0 as same as r and theta. This r and theta are called polar coordinate system. And your original point, that is x0 y0, is called Cartesian coordinate system. Okay, so what is the relation between x0 y0 and r and theta? So if you know x0 and y0, then you know by Pythagoras theorem what is the value of r. So clearly from the Pythagoras theorem, r square is equals to x0 square plus y0 square. So your r is equals to x0 square plus y0 square root. Okay, if you know values of r and theta, then you can find out x0 and y0 also. What is that? So if you know value of r, then first of all apply the cos theta in this triangle 0 0 x0 0 and x0 y0. In that triangle, if you will apply cos theta, then cos theta is x0 by r. So that implies x0 is equals to r cos theta. In the same triangle, if you apply the sin theta's formula, then sin theta is equals to y0 by r. From that, you know that y0 is equals to r sin theta. If you know this and this, then you can find out the relation of theta also. That is from here, theta, let apply sin theta by cos theta. So we are having tan theta. Ratio of this will be tan theta. Okay, so it will be y0 by x0 because r will be cancelled. So it is equals to y0 by x0. From this, you can get theta is equals to tan inverse y0 by x0. But this is not a final formula because if you are in the first quadrant, then this will be okay, or you are in the fourth quadrant, then also it will give you exact answer. But in the second and third quadrant, you have to be quite careful. Why it is so? Let me explain you. Let one point, say point is 1 1. That is your x0 y0, means the points given in Cartesian form. Then I want to convert this point in the polar form. So to get the polar form, first of all, r will be the square root of x0 square plus y0 square, that is 1 square plus 1 square, that is 1 plus 1, that is 2, so square root of 2. But if you will apply theta, then theta is tan inverse 1 by 1, because y0 by x0 is 1 by 1, that is tan inverse 1 is 45 degree, or it is same as pi by 4 in radian. You know the relation between radian and degree, okay? Now if I take another point, that is x0 y0, here say this point is a, and I am saying this point be b. This r is depending on a and theta is depending on a. Now for the b point -1 if I evaluate rb, then it is again square root of -1 square plus -1 square, that is square root of 2, and theta b is tan inverse -1 by -1, but that is again tan inverse 1 is 45 degree, or pi by 4. So if I write this x0 y0 in the polar form, it is square root 2 pi by 4. If I write this in polar form, then it is square root 2 pi by 4. But it is not the given point. If see, I draw in this way, so pi by 4 angle from x-axis. So is this is your x-axis, and you are walking root 2 and distance. So you are reaching to the 1 1, that is okay, but you are not reaching to the minus 1. Okay, here you are reaching to the 1 1, that is okay, but here you are not reaching to the minus 1 because minus 1 in this direction. So while observing the theta from this second and third quadrant, you have to be careful, and either you can say that this is minus of distance because in this direction you are walking negative, okay, or you can write it as root 2 pi by 4 plus pi because of this pi angle. Okay, so this thing you have to be keep in mind. So whenever your points are in second or third quadrant, while calculating the angle, you have to be careful. Okay. So with this information, we start with the first problem of our practical. Find the polar coordinates of the following points having their Cartesian coordinates in R2. Find the polar coordinates of the following points given in their Cartesian coordinates. Okay, so the first problem is root 3 minus 1. So first of all, observe that where this point actually is. So root 3. So this much unit and minus 1. So somewhere here. So root 3 minus 1 means this point. So it is in the fourth quadrant. Okay. Now what is R formula? That is R is square root of x0 square, that is root 3 square plus minus 1 square, that is square root of 3 plus 1, that is 4 square root, that is 2. And theta is tan inverse y by x, that is tan inverse minus 1 by root 3. I can bring this minus common because tan is an odd function. So here it will be minus tan inverse 1 by root 3, and tan for which value tan is getting the root 3, that is minus pi by 6. So here that is pi by 6, so here this is minus, so it is minus pi by 6. Okay, so the polar coordinates of this point is 2 minus pi by 6. Okay, now let's move towards the second problem. Better I continue with the same symbolism. So 2 point is minus 1 root 3. Then R is equals to, R is clear, so I am directly obtaining that. So minus 1 square plus root 3 square, that is minus 1 square is 1 and root 3 square is 3. So again 4 square root is 2. Also see your point is minus 1 root 3. So minus 1 is somewhere here and root 3 is somewhere here. So this point is you are given minus 1 root 3. So it is in the third quadrant. So while evaluating theta, you have to be very careful. First of all, let me think about one triangle, so you can directly get that what actually is happening. So this is your y and this is your x. So if you will apply tan inverse y by x, which angle you will obtain? Here, this. Okay. So tan inverse y by x is tan inverse root 3 by minus 1, that is minus of tan inverse root 3. For which value tan is getting root 3? That is pi by 3. So minus pi by 3. Here ignoring this minus sign because we are getting this theta, okay, and we have taken this negative sign, but there is no need of taking negative sign. So here if you will ignore that, then you are getting this pi by 3, okay, and for that pi this angle is pi by 3. So what this angle will be? Since from the similarity, I have continued this line, okay. So from the similarity of angles, this is also pi by 3, but you are in the negative direction, since we calculate in the counterclockwise. So in the negative direction, we are having this is minus. So angle is minus pi by 3. So theta is minus pi by 3, and you are walking in the opposite direction, okay, means if you think about theta is equals to minus pi by 3, then you are in this direction, but you are walking in this upper side direction, so you are walking in the negative side, so you are taking, we can take this r as a minus 2. So the polar coordinates of minus 1 root 3 is minus 2 minus pi by 3, or if you are not interested in writing this in a minus values of this r, then actually you have to evaluate this angle, so that the whole angle is pi and you are having this pi by 3 subtracted, so pi plus pi by 3, pi minus pi by 3. So in that case, so either this, or if you are interested to write this in positive, so it is 2, and pi plus pi minus pi by 3, total is pi, and you are subtracting this much pi by 3, so this much is pi minus pi by 3. So pi minus pi by 3, it is 2 pi by 3, okay. So polar coordinates of this is this. Okay, you can further continue. Again, you can count again 2 pi and you will reach to the same point. So either you can write this as this, or again you can write 2 plus 2 pi by 3 plus 2 pi. Again you can add 2 pi and so on. So I can write 2k pi for k in z, that is integer set. Okay, but we are enough for this much, so we will stop our problem here, but this is just for your information. Now we move towards the third question of the same problem. So let take point minus 1 minus 1. So point minus 1 is somewhere here. This is your x-axis and this is your y-axis. This is your origin. Okay. So you have to evaluate this angle theta and this distance. So this distance is known to you by the formula, that is minus 1 square plus minus 1 square. That is minus 1 square is 1 and minus 1 square is 1. 1 plus 1 is 2, so square root 2. And theta is tan inverse y by x, that is tan inverse minus 1 by minus 1, that is tan inverse 1. Here I am taking the angle this, okay, this is your y, that is 1 and this is 1. So tan inverse 1 by 1. So you are getting this angle theta. So tan inverse 1, it is pi by 4. So this small angle is theta. So now whole angle is pi plus theta. So that is, all I have to do is add pi extra. So that is pi plus pi by 4. So 5 pi by 4. Or you can think as this way also. You are in this direction, that is with the pi by 4 angle, and you are working in the negative. So the polar coordinates, let me write here first of all. So polar coordinates of minus 1 is, first way it is root 2 5 pi by 4, or you can think about this pi by 4. So angle is pi by 4, and you have walked yourself in the negative direction, and that negative direction's distance you have walked is root 2. So we will write here minus root 2. Okay, so this is same as minus root 2 pi by 4, or you can continue with adding 2 pi infinite many times, you know. Okay, now let's take one more example so you can get it clear. Let's take the point 3, 4. I am taking the simpler one, so you can directly evaluate. R is equals to square root of 3 square plus 4 square, that is square root of 9 plus 16. So it is square root of 25 is 5. And point is already in the first quadrant, that is 3, 4 is here. So there is no need to think about the angle theta, that is theta is tan inverse y by x, that is tan inverse 4 by 3. Okay, so the polar coordinate of 3, 4 is distance is 5 and angle is tan inverse 4 by 3. Okay, so this is one side. Then let's move towards the second side, that is example number 2. Find the Cartesian coordinates of points of following points given in polar coordinate systems. Okay, if you have observed, then for the conversion from polar to Cartesian, we were thinking about the simple that x is equals to r cos theta and y is equals to r sin theta. So let's take the first problem. So first problem is root 3 pi by 6. Then its x coordinate is root 3 cos pi by 6, and y coordinate is root 3 sin pi by 6. Cos pi by 6 is root 3 by 2. So root 3 times root 3 by 2, so it is 3 by 2. And sin pi by 6 is 1 by 2. So root 3 times 1 by 2, it is root 3 by 2. So the Cartesian coordinate of given point is 3 by 2, root 3 by 2. That is quite easy. Okay. Let's do the similar thing for another point. Your point is minus root 2 minus pi by 4. So your x is again r cos theta, y is r sin theta, r, that is minus root 2 cos minus pi by 4. Here it is minus root 2 sin minus pi by 4. But cos is even function, so it is minus root 2 cos pi by 4. And sin is odd function, so it is root 2 sin pi by 4. And you know that cos pi by 4 and sin pi by 4 are 1 by root 2. So minus root 2 times 1 by root 2. And here it will be root 2 times 1 by root 2. So this is minus 1 and this is 1. Okay. So you know how to write the Cartesian coordinates of given points is minus 1, 1. Let's take the third problem from the similar question, that is root 3 minus pi by 6 is given in a polar and you have to convert in a Cartesian. So x is equals to r cos theta, that is root 3 cos minus pi by 6. Cos is even function, so it will be root 3 cos pi by 6, that is cos pi by 6 is root 3 by 2, so root 3 times root 3 by 2, that is 3 by 2. And y is r sin theta, that is root 3 times sin minus pi by 6, that is root 3, and sin is odd function, so minus will be outside here, sin pi by 6, and sin pi by 6 is 1 by 2. So here it is minus root 3 times 1 by 2, that is minus root 3 by 2. So you know the statement you have to write is the Cartesian coordinates of given point is 3 by 2 minus root 3 by 2. Let's take the similar last problem from the same question, that is minus root 3 pi by 3 is given and convert in a Cartesian form. So your x is r cos theta, that is minus root 3 cos pi by 3, that is minus root 3 cos pi by 3, so it is 1 by 2. So it is minus root 3 by 2, and y is r sin theta, that is minus root 3 sin pi by 3. Sin pi by 3 is root 3 by 2, so minus root 3 into root 3 by 2, so it is minus 3 by 2. So again at the last you will write the Cartesian coordinates of given point is minus root 3 by 2 minus 3 by 2. Okay. So at home you apply similar problems, test yourself that you are able to solve such problems or not. And stay at home, stay safe. Thank you. We will continue this practical in next lecture.